We live. What are we doing today? Oh shoot, I'm showing my stats. What are we gonna do today? We're gonna do Advent of Code, day 7. Dude, it's 14 minutes till it drops. Everybody get on the stream. Everyone get on that stream.
Day 2 job shadowing.
James Peralta 12 stars. This is gonna be crazy. Let's just like warm up with some leak code question. So I'm gonna practice with like number of islands or something.
Are you trying to get this closer to your mouth or something?
Dude, I'm just prepared to go to war today. This is gonna be a hard question, but
I'm gonna check your stream.
I'm gonna bring out a pen and paper too. Actually, I'll be right back. I'm gonna get a pen and paper. If anybody's watching, go on Replit too. Replit. I need to pay for this stuff. Oh.
I'm at your hour right now.
Dude, this is gonna be crazy.
Oh yeah, you gotta give that code.
Yeah. I'm gonna put in your VS Code somewhere. Or let's just go. You have your GitHub, right? Create a new gist. Advent Code day 6. Alright, we're going to day 7. Let's just do like some basic algos. Let's do. Hold up. I'm just gonna get a pen and paper quick. What is my? What's
You have
the
to
name of my
use
stream? Day
Excalibur.
7.
They have in the code.
Yeah, I'll use Excalibur, but I need to use a pen and paper.
Okay, guess I'm doing the stream right now. What is this code?
Entertain the people. So there's gonna be people watching the recording. You gotta.
Just cut that out. Cut the initial part out of this stream. No edits, eh? Oh my
That's what the stream is
goodness.
about.
Okay, I'll show them my code that I wrote today. These questions literally took me 2 hours to complete. Maybe I'm gonna try to finish this question. Do you want to do this easy lead code question?
Which one?
I'm stuck on this actually. Given a string S containing just the characters, these different brackets.
Let me check it out. This is not no easy question, bro. Given a string S containing just. So open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Okay, this is how I'm going to do this. You're solving this?
Yeah.
How are you thinking of doing it?
So initially I made a dictionary because like if you go down, like one condition is they all kind of have to be like equal, right?
Yeah.
So that I started trying to kind of build a table or like a dictionary. And then I was going to start making some statements like this. So if like the current pointer plus the next pointer are like this, like if this and this or this is those, then return false.
Okay.
That's kind of what I was thinking.
I'll show you how to do this. This question, I wouldn't expect anyone to be able to do this question unless they worked with stacks.
Are you kidding me?
You start with a stack.
What
You know what a
was I
stack
doing?
is? You know what a stack is? First in, first out. So okay, you essentially start like this.
Oh man, I wasn't even solving it right.
First you look at the first element, right? When it's like one of these back ones, you just throw it on the stack because eventually it's going to be closed. Okay, this is a stack. Put this in. Right. Then we move to this one. Throw this in. It was kind of trippy. I'm gonna say I'm gonna remove the other brackets.
Yeah.
Let's see. So we start for this one. We throw that in. Then we grab the next one. And then we throw this in. And then we see the next one, right? Okay. We compare it to the last element on the stack to see that if it closes it off properly.
Right.
Pretend it was like another one of this, right? When we're looking at this element, we're comparing it to the last element of the stack. You see that it's not valid. So you automatically return false, right?
So you would have to do an if statement for that?
Yeah. Or another, but like pretend it was this one. Then you like close, you can close that one off and you pop it out the stack.
I see.
Then you move to the next one, that's off, and you pop it off from the stack. That's kind of the solution. Yeah. If you see, let's see. Dude, that's a lot of code. Where is it? So you see this one, it works too, right?
Yeah.
Let's see. You see why a stack works?
Yeah.
Now I just have to write code. Keith, come say what's up.
Hello.
All right. What are we gonna do? So I'll show you how to implement this. Awesome guy, what's up? Nice to see you again. Where are you based again? Try what? This question? Do you know this question?
I tried that. That was me.
Yeah.
That was me.
John Prout the CFA tried it.
Show him like the ones that I actually beat. Tell them how I got stuck on that one where I tried to make a list and a list right above it over there. Problem.
Submissions.
Oh no. That's a lot of red.
Which one? Oh wait, when's admin a code dropping? 7 minutes? Goddamn. Awesome guy. Are you trying out the challenge today? I forget where you're based again. 2149 and over 1 space. 2149. Oh, you wanted me to try that one. Were you practicing on that? I'm sorry, man. I didn't get the chance. Let me look at it real quick. So you're given 0 of even length consists of equal number of positive and negative integers. You should return the array of num such that the array follows the given conditions. Every consecutive pair of integers has opposite signs. Okay. Oh, nice. Okay. I remember, you were asking me about this. Okay. What am I thinking
it was
here?
to help the
yeah. Okay, let me look at this quick. We have 7 minutes, but I can get to it. I think it might be like some 2-pointer solution. Because it wants you to do it in O of 1. But it said it's not required to do the modifications in place. Return the modified array after rearranging the elements to satisfy the aforementioned conditions. So you're given an array of integer numbers of even length consisting of equal number of positive and negative integers. You should return the array of nums such that the array of nums follows the given. Every consecutive pair of integers has opposite signs. For all integers with the same sign, the order is preserved in which they are presented in nums is preserved. The rearranged array begins with a positive integer. Let me think. One way I'm thinking is you kind of just do like a bubble sort.
Dude, you should see the questions that I'm doing. It's not good, bro.
Like one way I'm thinking is you kind of one way to do it is you bubble. One way I'm thinking is you kind of bubble sort everything so that it ends up like you bubble sort the negative elements down. So you see 2, right? Then you swap 5 and 2. Right. Then you see here, then you swap -2 and that. Something like that. Now you have them sort of in the right order. Now you just kind of need to swap. Let's see. Now let's think about it. Now this one should go right here. Now you want this one to go right here. -2, but that swaps the 1. Okay, let's do that. Sorry. So we swap the -2 and the 1, and we get the 1. Oh, but that swapped the order. Let me think. Ooh, that's actually a good question. Not gonna lie. Let me think. The most brute force way to do it. Oh shoot! Did I close it? I mean, the most brute force way to do it is literally just create another array with all the negatives. Think about placing like plus minus, plus minus, plus minus. But should I sort it like right away? Yeah, that's what I'm like. I want to know where to put the plus, or I need to know that all the pluses and the minuses are all on the same side. Like I want to partition the array so that we have all the positives on one side and all the negatives on the other side. And then from there, I want to, what's it called? Then I want to like start placing them. But one way I'm thinking is literally just create extra space. Yeah, one thing I'm thinking is we order it like that, right? And then we create another array that holds like the -2. Hey, the mod is in. The mod is in.
Nice.
The mod is live. Let's get it. Like it said, you don't really need, like right there it said it does not require to do. Oh, you said extra space. Hey Mark, what's up? I'm about to do Advent of Code in about 3 minutes. But then
You gotta finish this.
yeah,
too.
he's awesome guy's trying to fry me right now. He gave me a pretty good question. It has a high acceptance rate, but I think there's a easy way to do it and then there's a complicated way to do it. Let's see. Let me think about it. Nice, we got 9 people. Awesome guy. I'm gonna have to get back to it as soon as this lesson starts, just because a lot of people are tuning in for this Advent of Code, and I need to get to it. But
We'll get it. We'll get it soon.
I
We'll
won't.
get it
I won't
soon.
stop this stream until this question is done. Trust me.
That's a
2 minutes. 2 minutes.
That's a guarantee.
Dude, last one was really good. I figured out how to actually do it on my drive home. It just came to me out of nowhere, and I dropped the solution on it. I have a video on dropping the solution. Yeah, I won't stop this stream until I solve that question. Can you give me a better hint? Like, give me a better. That's a really good hint of placing the plus and minus, but is there any other hint?
This guy's begging. Oh my god.
Just gonna be. I suggest everyone also hop in and we can do this crowdsourced for real. Mark, not really.
I
Not
talked a
really.
little bit about the tariffs today.
There's tariffs.
That's-
Oh yeah.
the one
he
from
he.
the start.
This guy's a finance channel, so he
I'm
talks
not even
about that
worried
stuff.
About the,
You're not
I'm
worried about the tariffs.
nothing right now. The market's hot.
Follow my brother. My brother as well. He does finance content.
Why are you worried about the? Why are you worried about politics, man?
So my brother predicted a Trump victory. Honestly, let's see. Trump with CFA. Follow John Prout the CFA.
Yeah, go into videos.
But yo, okay.
From my side.
Awesome guy knows what's up. Okay, I can tell you're in the industry. I can tell you're in the industry. I think you. I can tell you're in industry.
That's good.
This guy's good. Okay, yeah. Don't give me no more hints. Don't give me no more hints.
No man.
I want to join your company specifically, bro.
Wait till it vests. Yeah, I heard about that too, though.
You're just trolling, man. You're
Yeah,
just trolling.
I would welcome that, to be honest.
No.
Actually, maybe not.
We'll get to that
We
question.
already operate like a 51st state, anyways.
Yeah. Awesome guy is. Yeah, this guy's smart. He knows what's up. All right, 3. So the historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on the side of the bridge though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing around and stole all the operators from their calibration equations. Sounds good. Are you solving leak codes daily too? So let's see. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equation. This is your puzzle input. Each line represents a single equation. The test value appears before the colon. This is the test value. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. So is there any way to produce this value given the other ones? Operators are always evaluated from left to right, not according to precedence rules. Further, numbers and equations cannot be rearranged. Glancing into the jungle, you see that elephants holding two different types of operators, plus and multiply. Okay, so only three of the above equations can be made true by inserting operators. Okay, I'm already starting to think of I'm already starting to think of like a brute force approach for now, but this one's a little bit easier to grasp my head around. So only three of the operators. So 190 has only one position that accepts an operator between 10 and 19. Choosing plus would give 29, but choosing star would give you the test value of that. So this one has these four operators of the four possible configurations of the operators. 2 cause the right side to match the test value. Okay, cool. So this can be solved exactly one way. The engineers just need the total calculation, which is a sum of the test values from just the equations that could possibly be true. In this list, okay. How's everyone feeling about this challenge? Do they get it? Do they get this one? I have a solution, but I just kind of want to see what everyone's thinking. Like, what are the different approaches? I think I'm going to do a backtracking algorithm. Does anyone understand what's going on here? Or everyone understands what's going on? I think it might just be a pretty basic backtracking algorithm. Not that that's easy to write, but I think that's something we'll do. I don't see anything in the chat, but everyone should try this out as well. So what I'm going to do, John, is kind of brute force it. It's going to be like a backtracking algorithm.
It's like the 2-something.
Well, I guess, let's see. So first you're given 10, right? And you're going to have to evaluate. This is our line. We're going to try 10. And then for each one, we're going to try 2 paths, right? Either plus or multiply, right? And the next one is going to try to multiply is 9, or what is it? 19. And then the other one is going to try to multiply is 19 here. So this one, you'll see what's 10 times 90? 19, 190?
Yeah.
Right? And what's 10 plus 19? 29?
Yeah.
So we know right away that that we can get there. There's a path, right? If all of these turn red, then it's not valid. But pretty much for every case, we're gonna pretty much loop down and try the different ones. Like, so for example, let's do one that actually works. 81, 40, and 27. Let's just run through this example. What I'm gonna do is I'm gonna start with 81 like that, right? And I'm gonna put a pointer at the first one. Wait, let me adjust this quick. So I'm gonna put a pointer at this first one. Let me increase the size of this. Interesting. Why is it?
It's too slow now?
No, it's good.
Dang.
So what I'm going to do is we're going to start a pointer at the first one, and that's going to be like our element here. We're going to say 81, right? And then from there, from 81, we're going to try, we're going to recursively call, like we're going to call the next one. the next number. We're gonna start 81. We're gonna call the next number, but we're gonna try two things because we need to take into account all of these numbers. So we're gonna try pretty much two pats, right? We're gonna try for two pats 40 right here, 40 right here. This one is gonna be like plus, and this one's gonna be multiply, because these are the only two operations that we care about, add and multiply. And then finally,
What about the subtract and divide?
it doesn't say that, right?
Does it?
Two operations. So we do 27, 27, 27, right? And then from here, these are like the different, all possible ways that we can get it. And it could be modeled as a tree. What is here? You try plussing, here, plussing, then here, try multiplying. And okay, what do we get here? What's 40 plus 81? 121? Right? What's 121 times 27? 121 plus 27.
121 plus 27? 138?
Yeah, you're right. 148.
Holy moly.
The math. 127. 148. Right? What is this? 121 times 27? I haven't implemented a backtracking algorithm for a little bit. So that's that. But we're going to do this right on stream. 40 plus 27. What is that? 67? Right? 40 times 27. I'm just going through one example just to get it through my head. 1080. Right? And it said the left side is 3267. And one of the paths equal 3267. So we know that it's valid. And now that we know this path's valid, we know like there's a certain way that we could return that, and then we just return the result. So pretty much that's what I'm gonna do. I'm gonna build a backtracking algorithm that's gonna sort of build this tree, and for each element, it's going to try to like we're gonna start with the first element. And then we're going to we're going to build out this tree all the way down until the bottom. And then we're going to see if any of them equal the very left side of the equation. Hope that makes sense. Let me just quickly, how do I stretch this out? That makes sense, everybody? Let's just make sure that, let's parse this input.
Damn, you're locked in today.
Dude, there's way less distractions today.
What was the distractions yesterday?
Cedric? No, that's kidding.
He's pulling up.
My friend Cedric's gonna come again. We'll have Caesar on here too. Let's do split. Yeah, my brain was fried yesterday, but also I flew all the way from San Francisco.
Yeah, and you did like you taught me for like an hour before.
No, there's no excuses for not being able to solve that question, bro.
Oh my god. Mamba mindset.
Okay, what we're gonna do is we're going to for every line in the input string, does that make sense, John? Like what we're gonna be like
yeah,
pretty much building all the paths.
Explain the split and you kind of rearrange it again. 1 minus 1. What was that?
Where?
Go back to the code. Oh, I'm just asking some basic questions.
Oh, this is
Man, I'm not higher ready though.
this is like is like ignoring
just
the
go
string.
Go from the bottom to the top.
Yeah, so this is ignoring, because when we parse this, you'll see if we didn't do that, it will like take this as a line, and then it'll take like I think the bottom as a line too.
Right.
As a new line, but we don't want to. We only want these lines. So let's just like do this print string.
You just want the middle pieces?
Yeah, see 1019.
Okay.
Watch. Pretend we didn't do that.
Oh, I see.
Or sorry. I'm splitting by that, but pretend I didn't take the first one. You see adds extra line there. Adds extra line there.
Oh.
So I have to slice the array.
Okay, you just naturally. do that.
Caesar. Okay, what I'm gonna do? I'm gonna take like the expected result, and I'm gonna take the line, and I'm gonna take the split, and we're gonna do like that. Expected result, elements. So we're gonna print. Mark, I use Replit for just quick prototyping, but I usually do VS Code. If you want to study algorithms, literally just study LeetCode on here. LeetCode
Do you
It's
ever
pretty
use
good.
Jupyter Notebook?
They have like not really. Oh shit! Sorry, I swore online, but I didn't want to click on the solution, but what's it called? Use
This guy
LeetCode.
Tried to cheat.
Use LeetCode.
Oh man, that's a negative.
No, I meant to show
That's a
that.
negative signal.
Awesome guy. Please don't count that as a negative signal towards my hire. Let's see. Okay, so for line here, we're gonna split by the line, and we're gonna get the expected result here.
Mark Paula, what do you write in, and what do you like to
Yeah, like,
use?
where are
as
you-
that,
yeah,
like
where-
IDE or text editor.
Yo, Mark. Hey, Mark Paul. I'm gonna send you this thing. Come here. Yeah, exactly. Choose your nose.
You don't use a text editor?
Let's do. Yo, Mark Paul, sign up for my giveaway. What's it called? I'm giving away a bunch of money and tutoring. Let's see. How do you do this?
Just copy and paste it.
But I want to know where you are at in your coding journey here. Oh, LeetCode hard. Okay. Light. Oh, he's already done.
Light
Oh my
one
God,
today. Who's
okay.
it? Oh my.
No way. Okay. Sorry. Let me focus up. So we're given 190, 1019. We'll take the elements and we'll split it. We'll say terms equals elements dot split. And we'll split it by new line. So now, let's just do this. You're right. You're right. LeetCode hard. So we're given the term here. The expected result is that, and we're given these terms. So now we're gonna want to do some sort of backtracking algorithm or brute force. So what we're going to do there is we're gonna do let's say backtrack. I haven't implemented a backtrack algorithm in like 6 months. Let's see, backtrack. We're gonna give the current current sum target, and we're gonna be
That's
given
gold, man.
current sum target, and we're gonna be given like an index. So we're given the current sum, a specific target, an index, and the elements. Right. If the index, the base case is if the index is equal to the length of the elements, we'll return current sum equals the target. Right. Otherwise, what we're going to do is we're going to, for that specific index that we're looking at, we're going to try adding it to the result and looping. Return. We're going to do backtrack. We're going to do backtrack. We're going to either try to add it. Add to. Okay, added equals, you take the current sum and then you plus, let's see, candidate element equals the elements at the specific index. So that snatches the index that we're looking at. And what we're going to do is we're going to take the current sum and we're going to add, let's do added equals backtrack. We're going to take the current sum plus the candidate element, and we'll pass back the target. We'll pass in index plus 1, and we'll pass in the elements. and we'll try multiply this solution. And we'll do backtrack. We'll take the current sum. We'll multiply that by the candidate element, target, and we'll do index plus 1. Then we'll also pass in the elements so that it could go through the elements, and we'll return if added or multiplied. If any of these worked, we're good. So pretty much what we're gonna do is,
Man, that not hard joke is killing me right now.
awesome guy. What is what? By the way, what's the advent of code thing? The advent of code thing is pretty much they drop every single day. They drop it's just a challenge. This challenge been going around in the industry. It's pretty popular in the Bay Area. But pretty much the 25 days leading up to Christmas, they'll drop a new coding challenge every single day. And the coding challenges get like harder and harder. So by the 25 day, they're asking like combinatorials, bunch of like really hard math problems. But for now, I think it's just simple backtracking. But yeah, tune in. Like every day they drop 2 questions and you just solve them. If you solve the first part, you get access to the second part. And if you solve both, you collect, like for each part you solve, you get a star. So for each day, I already collected 1 star. So I have like 12 stars. So I'm working on today. And let's see, where am I at? Okay. I'm not catching the base case though with there's only 1, but I don't care. What I'm going to do is I'm going to say if backtrack of, I'm going to take backtrack of, let's say expected result or terms, the 0th element. And I'm going to do expected result right here. And I'll do index. We'll start at 1. And then I'll pass in the elements. If that's ever true, we'll have a result here. And we'll print the result. If that's ever true, we'll do result. I have a bunch of friends over. There's a lot of us over today. But what we're gonna do is
we won't leave until that one lead code question is done though.
Yeah. We'll solve that lead code question in you wanted ov1 space. Honestly, I hate when interviewers ask me for ov1 space. It's so funny. Guys, make sure you do 3-sum and 4-sum. Make sure you do 3-sum before doing 4-sum immediately. This guy's funny. You actually can't multiply sequence. Oh my god. Okay. What I need to do is for each of these, for the expected result, I want to take the expected result and I want to turn that into an int. And then for the terms, what I'm going to do is I'm going to apply a lambda function. And I'm going to take every element and I'll just convert every element to an integer. And keep it as an iterable. Terms. Hold up. Strip in.
Does the lambda have to have squares?
Invalid syntax. Lambda. Square brackets. Oh, sorry. Map. Lambda. I've probably been coding for like 10 years.
I've been coding for like a month. Holy.
I started coding only in college.
Show awesome guy my code later. He's gonna. Oh man.
I started only
Tell me if it's optimized.
Wait, print terms. Oh shoot.
I literally started lead code. Like I did my first lead coding question today.
What do we have today? So that's the code. I think it works. Let's just run it in here. It's a little backtracking algorithm. Let's see if it fails. Please work on me today. Oh shoot. Yeah, 10 years. I've been coding for 10 years, but I started in college.
Show them your Git repo.
Show my Git repo.
Nah, focus up. Listen
Dude,
to that one.
I'm trying to literally.
Why can't you copy and paste it?
One star, baby. One star. Baby.
That was
locked in today.
I guess
locked
you're the
in.
same newbie who feels cool after solving two-sum. Bro, I did not solve two-sum.
He couldn't solve.
I could not
It's not.
solve
It's not
two-sum.
easy, man. It's not
Oh,
easy. It's not
man.
easy.
Trust me on that.
Dude.
Show this awesome guy my code. I know my code's.
I'll show it.
doggy
Let me
code,
get to.
dog
Let me see how I ranked quick. Probably kids are solving this so fast. Oh, I placed top 4K. Okay. The engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety. Just then you spot your mistake. Some well-hidden elephants are holding off a third operator. Concatenate, combining the digits from its left and right inputs into a single number. Okay, all are still evaluated left to right. Now, apart from the three equations that could be made true by using only the addition and multiplication, the above rank has three more equations. What is this?
Oh, yo, he must have been watching back in the day, hey?
Who? Awesome guy?
Because I am that same newbie, bro. Yeah, that was me.
This guy. He's saying he is
Dude,
that
I
noob.
could not solve that thing, and then I ran it. Man, I thought I was cool generating Python code, and then I realized like this
Cannot be.
sucks compared to just knowing how to code. And then that's kind of what got me started with coding.
Yeah, he just started
I
coding
started
about like
2 months ago.
Okay,
Maybe? A month ago.
I'll finish this question right now, and I'll work on rearrange array, and I'll just start spamming lead code questions for the next 6 hours. Just kidding. Hopefully this is not too hard. So the engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety. Yo, John, get Cedric here. I need one of my fitness friends is gonna come talk about his fitness coaching business. He does online training, and he's gonna tell everyone who's doing software job why they need to be working out every single day to be highly efficient. That's what he says, and I just follow what he says, honestly. Some well-hidden elephants are holding a third type of operator, which combines digits. For example, would become all operators still. Now, apart from the three equations that could be made true using only addition, the above example has three more that could be made. Okay, all we need to literally do... Awesome guy is really trying to test people, put people...
If he does,
He wants to make Cedric do a lead code question. He wants to see someone go through it.
That guy cannot solve a lead code question, man. Ask me a finance question on the fly. Ask ChatGPT.
Dude, why is this question so
Give me
easy
a
today?
Finance question. Let me see if I could test. Let me see if I'm good.
Int.
Yo. Oh, bad. Eric Brown?
Eric D. Brown.
Disney guy knows what's up.
You should always code in dark mode because the light attracts... Dude. There's no bugs in my code today. There was some bugs in my code yesterday. But... Let's see. Moment of truth. We did it!
Oh my.
We did it!
What? I didn't even
We
get
did it
to
in
watch.
record time today.
Holy, you're locked in today.
I was locked in today.
Oh my god.
Yo,
What is this chat?
this chat is getting... This is what happens when you go live on the internet.
Yo, see,
But yo,
don't
guys,
ban him though. Don't ban
guys,
him,
check
though.
this
I don't
out.
think that's...
I ranked really high today. This was my best showing. I finished the first question in 20 minutes. And
don't ban him though.
and I finished the next one in
We
4
need
minutes
those
after that.
views.
Bro, this is getting crazy, this chat.
Oh god.
Yo, okay, now I'm gonna do this other leak code question. Awesome guy wants me to do this in O1 time complexity. That's crazy.
Wait. Get awesome guy to I'm lucky for you.
That's crazy.
What?
I don't know.
Okay.
I do not know what's going
Okay, yeah,
on.
yeah. You don't. He doesn't want to see my code, man. My code's dog water.
Yeah. So if anyone tuned in, O1 space, not time. Yeah, we're brothers. Nah, this is somebody we know. Yo, mod.
Yeah, yeah. Don't ban him.
By the way, Caesar is the mod, and he knows he's our lawyer, and he knows inside out.
Oh no! This might be.
This is getting crazy.
This might be Cedric because he has a C on his name.
They're getting exposed. Okay.
Oh my man.
So we
This
solved
guy's
it good
so-
today. Now let's do this. Let's do this. He wants to do O1 in extra time.
Ask your friend how's 2 plus 2
Yeah.
equal to 5.
Yeah. You might have to kick that guy. Kick. Yeah.
Oh no.
Pedal 30 miles a day on that. Nice. Do
Yeah.
you? That's good. Do you like do it during meetings and stuff? Because I've worked with coworkers who are always on like a standing treadmill while on all their meetings. It's pretty funny. It gets a bit distracting sometimes, but like it's a good way to stay fit.
Oh no. I don't know what this 2 plus 2 equals 5 is, man. Is that like a trick question? Is that a finance question?
Eric D, have you tried Advent of Code today? It wasn't that hard.
Don't tell me you got 2K or less.
Okay, we're gonna work through some more leak code questions.
Oh, what? That's a trick question.
So
man.
he's saying we rearrange this by like okay.
I was gonna say 2 plus 2 equals 5. That's like that's an arbitrage trade. You go long the 2 plus 2 and short the 5. That's what I was gonna say, but
We have to
my
reduce the
mistake?
gain. There's people laughing in the back. It's funny.
No, it's good. Don't change the
Okay,
gain.
okay,
Don't
okay.
change the gain. Keep the gain at
Because people keep saying who's laughing, who's laughing. Proof by deduction.
John Peralta CFA.
Yo, let me know what
But
topics.
that's an arbitrage
Yeah.
opportunity, man. Long and then long the left, then short the right. Read
Okay.
it again. 2 plus 2 equals 5. I don't
So you're
get it.
given a zero index array
Oh,
nums
man,
of
I'm
even
not that
length.
smart, man. Finance
Uh,
people are the donkeys of STEM.
You're given a zero index array nums of even length consisting of equal number. So it's kind of already telling you that it should be equal. Like it's already kind of telling you. Okay. It's already telling you a hint that it's going to be even length and equal number positive and negative integers. So what I'm thinking, let's see right here. Like we try to place the first positive index, right? And we go in here, since it's already positive, maybe we switch it, like since it's positive, we already know it's positive, we leave it as is. Then we go to 1, and then we know it's 1, we switch it with the first negative integer. Would that work? Dude, who's laughing like that in the back, bro? It's crazy. -2. Wait. Okay, so we're given this. 1 LeetCode medium equals completing Advent of code. Yo, do a dry run. Do a dry run of what? What do you want me to do? Oh, do a dry run of the question? Like dry run of what? It's lagging a bit. The stream. Every have opposites. Okay, yeah. I'll do a dry run of approach. So you're given a zero even length. You should return the array of numbers such that the array follows the given conditions. Every consecutive this guy might have to get kicked.
Hide you? Oh no! Why'd you hide
I
him?
don't even know.
Oh man.
What's it called? Yeah, kick that guy out. That's actually that's actually weird, bro. This is for professionals, honestly. Everyone who comes in this thing should be looking to learn and working on hard problems, not Like,
Acting crazy. He's a little tipsy. I think that guy's sober. He's
Yeah.
just like that. Unfortunately.
dude, we have a lot of concurrent people in this chat right now, 14 people. But at the same time, we already
Give
just
him a
solved all the
24.
questions.
Yeah, he'll learn.
Okay, now we need to solve this question, but I need to think about it hard, Richard. Dude, I hate the ones that people ask you to just like do it with O1 space complexity. Let me think of how to do it with extra space. So if I want to do it with extra space, what I'll do, if I want to do it with extra space, I'll create an extra array here. And then for all the negative values, I'll throw it into this array. Right? And I'm only proposing this approach. My favorite coding language is Python, but I'm only proposing this approach because I want to optimize it at the end. So all the negative ones, we pretty much throw in a separate array until we get here. -4. And I guess we can create like a second array here. We can create a second array where we insert our positive numbers. 3, 1, 2, right? Now, we pretty much just like build the result by like alternating like, or we use a pointer and we pop in, we use like a pointer here. Yeah, low level is annoying to deal with, honestly. Let's see. So maybe we start here like this. And then for the 0th one,
Damn.
we put 3 and
Austin, that's
-2.
Crazy, man.
And from here, we put like, we just pop it into here. 1, 5. Then we go to -4. Is that the result? Right? So that's one way of solving it. Let me just like write that answer really quick, just so that I can get that working. So it begins with a positive and negative integer. So what we're gonna do is, yeah, get that get kicked. Okay, what we're gonna do is we're gonna start with positive. Positives.
Caesar made a good move though. I don't know. I would have kept them in for the watch hours.
For num in nums, we're gonna do if the num is less than 0, we do negatives. You didn't even brute force. Do you know how to solve the 2-sum?
Nah. Maybe later. Maybe. Nah, I can't say. Okay, show this guy my code so we could all have a laugh.
Okay, he's gonna show
Yeah,
you.
yeah,
wait,
critique-
let me
okay,
quickly
okay,
critique his code. I'm literally just going to quickly implement this extra space algorithm, but it's still over in time complexity. Can you teach in Java or C++? I'm not a big fan of those languages. I can do some things in Java, and I'll drop a whole series on that, actually, specifically Java. But I'll show how to use like the tree map and how to build an array list from scratch using Java or something like that. I'll prioritize that in my channel next. Positives. I'm gonna be dropping a video this weekend on trees and graphs and heaps. So there's gonna be one video for each. One video for trees, all the theory you need to know about trees. And I'll be implementing like a tree data structure from scratch. That's 2 videos right there. I'll do graphs. I'll do a full video on the theory for how graphs work. and I'll do implementing a graph from scratch. Then I'll do a video on the theory for heaps, and I'll do implementing a heap from scratch. So those are 6 videos, and those are all coming out next week. So pretty much now we go like for I in range length of nums divided by 2. We're gonna do just then what we're gonna do is for I in range, you don't need to return it. Bruh.
He's back.
For positive and negative integers. So what I'm gonna do is for I in range, positive and negatives, I'll say while the length of positives equals for x. You're right. That's way quicker. Yeah, you're right. But then I like that. That makes sense. But then for nums right here, what I'm gonna do is now I just need to construct the final array. So what I'm gonna do is like while I'll have an index here. While the index,
Eric's saying something.
yeah, you're right. You can zip it. But while the index is less than the length of nums or length of positive, what we're gonna do is we're gonna take nums. So index num equals positives at index. Then we're gonna take nums index plus 1 equal negative index.
What's that? What does that mean?
No idea. Oh shoot. I accidentally ran it. I didn't increment this. What happened here? 3, 1, 2, 2. So increment by 2 here. Wait. For I in range. So I'm just gonna loop whatever. Let's just make a, since we're already using extra space here, we'll just build a result. And yeah. We'll do this. We'll do for pair in zip positive. I'm not gonna lie, awesome guy. Like these arrays with O1 space is not my strong suit.
Oh no, he's backpedaling. He's already backpedaling.
Pair 1. Let's just get that working for now. Extra space. I'm thinking of a way to do it with 2 pointers, don't worry. I just want to get this working for now. Is that not enough? Awesome guy? Okay, now let's think of a more optimal space. How much space does this actually use? This is uses like basically O of n space complexity. If we combine both of these, then we're creating a result. That's another O of n. So in total, it's like we're pretty much using O of n space complexity and O of n time complexity. So our time complexity is O of n, and our space complexity. This is my brother. He just turned. Come see what's up. This guy just turned 18. He's legal. Hop in the scene.
What up, chat?
What up, chat? Oh god.
You saw chat.
That he's flexing my giveaway money. That's the money I'll be giving away to my subscribers. Show that two-sum solution. Which two-sum solution? Okay.
Mine?
Yeah.
My two-sum solution? Okay, go ahead.
Where? Yeah, he's gonna show you his
I don't
two-sum
know.
slution real quick,
Wait.
and I'll be back to spam more leak code questions.
I'm
Show him your
scared,
solution.
man. I don't
Show
know.
him.
I didn't
And
even
then let
solve it
them-
myself. He dances for sure. Okay, why are there so many goofs in this
Oh.
chat?
What's up? What's up?
The first female in the chat. In the videos. Just kidding.
John, show them your code.
Awesome guy. I really just started learning how to code like not long ago. Let me see. Okay, man, this Gymnos guy, he's on the road to getting canceled. Okay, how do you do this lead code thing? You want to see my... This was generated by ChatGPT though. Like, this wasn't me. I'll show you. Tell me if this code is good though. I know it's bad. Nah, not that one. Okay, tell me if you think this code is bad. This is code I wrote today, and I flopped for 2 hours trying to do it. Look at this. You copying pasting snippets, I see. What does that mean? I think that entire thing was copy and pasted. That wasn't a snippet. That was the entire thing. But yeah, looks good for a beginner. This one? Really? Holy moly. Show you this one. See this one. Looks great, much better. Oh no. There's a lot of cavemen in here. Okay. This one, I couldn't... This one? What do you think about this one? But I'll kind of show you like what I really do with code and why I'm not that good at coding. Yeah, I was asking Caesar for some advice earlier, man. I could not get it. I think like when I initially was trying it, when I sent it to Caesar, it was a for loop, and then eventually I made it a while loop on the last one. For sure. For sure. Let me take a look at when I actually started coding. But I thought I was so good. It was hilarious.
What's happening? What's happening?
Nah,
Showing you the code?
I'm showing them like when I first started coding, and I thought I was so lit at coding. I thought I was so good at coding.
Dude,
back when
it takes long to get good at
like
coding.
when did I do it? So my first coding to 0 to hero was like a month ago. So when was my first day? Like I'm pretty sure I started about like maybe this one. Or this is when I first started to code. Oh my goodness.
Click
what
up,
a
click
ad.
up.
October 21st is when I
Everyone
did
in
my
the chat,
first.
like, when did you start coding?
Yeah, man. I want to know. But check this out. This is basically my gateway drug into coding, using ChatGPT to write code to buy stocks, PE screening. And then I was like literally copying and pasting. Okay, imagine how big of a donkey I was. Like, Wi-Fi, like Yahoo Finance is like my go-to website for free like data, right? I didn't know what an API was, so I was trying to scrape the website instead of calling the API
But yeah, that was like my first code initially. It was so jokes. I was like literally copying and pasting it, right? And this is when I bought D2L. Like I was really doing analysis on D2L, and I'll show you like what my D2L return is right now. You're gonna laugh so hard. But yeah, I started this 1K to 10K challenge account. So I started with 1K and then I put like some money away every day,
How much are you at now?
like 4K.
You have 4K?
Yeah, let me show them my wins. But yeah, no, like I definitely am so happy I started learning how to code. I've been coding like at least an hour a day every day and no breaks. But now that James is back, like at home, I'm probably just gonna dominate. Like I'm just gonna
What's your strategy? Like, how are you gonna plan to get good at leak code? Did you watch my how to get good at leak code video?
Oh man, I think honestly, I'm at a point where I'm just gonna try to. I think I want to brute force my way to it. To be honest, I know that I should do the books and like read the books a little bit. But yeah, look. So my 40% up on D2L. Oh my god.
That's a lot of money.
40% up on D2L.
Log onto your phone quick. And then?
But yeah, like this was my first gateway drug. I was like really trying to analyze D2L. I didn't want to do it in Excel, and then I kind of started using ChatGPT to kind of like generate code for me, and then I got really good at generating prompts, and then I kind of tried.
Somebody wants me to look at some
first.
questions. They want me to.
What topic are you doing?
Why is that not showing up in the chat? Okay, well, chat. We're gonna look at a couple problems. We're gonna do a couple more problems now.
I was
LeetCode
entertaining
88
for too long. What was that? The ADD rant.
No, that's good. I need to merge sorted array. Oh, you think this is gonna fold me, bro? Okay, what is called? So you're given two arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements nums1 and nums2 respectively. Merge nums1 and what topic are you doing or will you do in the future? What do you mean? What do you mean by that? Sorry. We going live 8:30, yeah, 8:30 PST around that every single day. I'll have, except for tomorrow because it's my friend's 18th birthday and we're gonna hit the club. So cheers. We're just having a little drink.
Let's give him a John.
This guy needs chase.
Yeah.
We're just having
Yeah.
a coffee at it's late at night.
This is gonna be like we're gonna do a couple big collabs. Me and
Yeah,
James.
everyone's gonna be here. But
We're
what?
gonna get our like. There's a third Peralta in the family. He's gonna come in one time too. We're probably gonna do like watches, like investment watches, like literally like 10K.
Okay,
piece.
let me look at this. You're given two integer arrays sorted in non-decreasing order and two integers m and n representing the number of elements num and merge into a single array in non-decreasing order. The final sorted array should not be returned by the function, but instead stored inside the array nums1. So we're sorting it in place. And to accommodate this, nums1 has a length of m plus n. So it has extra space in there. And the last, our set 0 should be ignored. And nums2 has the... Okay, so we're pretty much given two arrays, and all we have to do is merge them. We're given these two arrays, and all we need to do is merge it. And the final output should probably be... the final output should probably be this. Right? I automatically just... I just like... The problem when you're working with arrays is like you don't want to overwrite elements. So if we try to build it up from left to right, we could overwrite the elements. So I think we just, yeah, like we do content. I do content for...
I'm learning, and he's kind of just doing it for fun.
Yeah, I literally do it for fun, but I want to also like teach people LeetCode and stuff. So what I'm gonna do is I'm gonna have 2 pointers, one pointer at this one and one pointer at the other one, and the larger of these values I'm gonna place at the back element. So I'll place it here. So what's larger, 3 or 6? 6 is larger, so I'll put that next, and I'll decrement this pointer. Which one's bigger, 3 or 5? 5 is, so I'm gonna add this to array and decrement this pointer. What's bigger, 3 or 2? And I'm like, there's another pointer right here, right? What's bigger, 3 or 2? 3 is a bigger element, so I'll put 3 here, and I'll decrement this pointer. What's bigger, 2 or 2? Doesn't even matter. I'll just throw like the bottom one, and now we have it as a sorted array. So awesome, guy. What do you think about that approach? O of n space, or O of 1 space complexity and O of 1 time complexity. I'll just code that up. Piyush, I'll tell you, we do leak code for fun. Do you even want me to code it up, or just give me another question?
Code it up. Let's see how. Should I code it up?
No, that's.
Is that hard?
Wait, open this up. I feel like our chat is delayed a bit. Oh, you want me to code it? All right. So we're merging 2 sorted arrays. Or just tell me what they're saying.
Okay, yeah.
So what we're gonna say is we're gonna position one element, one at the top and one at the bottom. So where are we? Right here. Merge 2 sorted arrays. So, and get ready to give me another coding question after. I'll just keep going like next and next and next. So we're given 1, 2, 3. And honestly, I would say I'm an intermediate level leak coder. So let's see, 1, 2, 3. We're given 1, 2, 3, 2, 5, 6.
I don't really know what O. I kind of know the functions that O of 1. What's the difference between O of 1 space and O of 1 time? Like, how are they different?
2 sum in
O of 1
O of
is
1
memory?
space? Is that even doable? So we're gonna have a top and we're gonna have a left point, or top and bottom. We're gonna do top, bottom equals are we given m? Okay, we're giving m. Top is equal to m minus 1, and bottom is equal to n minus 1. So for example, here they gave us 3, so we want to position ourselves at 2. Here we want to put the top pointer right here. What's up? We're live on stream.
No cameras, no cameras.
Top, bottom.
No cameras. No cameras.
So we do the bottom, n minus 1. What's n minus 1? We're doing n minus 1 is 3, so we position that at 2 again, and
I
we
could beat this
position
guy up.
1 at the very bottom at the let's say candidate index, length of nums 1 minus 1. That positions us about here on that array, and then pretty much like while the candidate index
You put your head down so you're like nice in the camera. It looks kind of
is greater than equal to 0, we're gonna be adding the result. So let's see. So now we're comparing them. While the candidate index is greater than equal to 0, we're gonna decrement this. Right. Oh, you want to do leak code 11? Let me look at it. Okay. I can do that question too. Let's see.
Damn,
Let's
these
see.
are light. I don't know if I could even solve this.
That's a hard question. Oh no, it's a medium question. I'll think of. I haven't seen that question in a long time, but I think I remember how to solve it. So maybe give me a different one. But I can talk through the solution. So if we talk about the candidate index minus 1, what we're gonna do is since we're starting at the other one, we're gonna keep decrementing it until it's the end, and we'll say like if top, what we're gonna say, like if the top, or we're gonna be comparing them. We're gonna say You guys have like a YouTube house? A few of the people, everyone in the house have done
The
content
mic's good,
creation
though. The
in
mic's
their
good.
in the past, honestly. But yeah, we're starting a content creator house, honestly. I dropped, my eyes are starting to burn. So if we do, we're gonna compare these two elements, the top and the bottom. If and top is greater than equal to 0 and bottom is greater than equal to 0. So if the nums 1 top is greater than nums 1,
Content creation on OL.
this guy's so funny. We'll do whatever it takes for money. So let's
Damn,
do.
thirst.
We'll take nums 1, or sorry, nums 1. We'll put in the candidate index equals, if nums 1 top is greater than that, we'll put that. Otherwise, nums 2, we'll put nums 2. One time, Ari. Top grade. Oh, sorry. See if I capture all the edge cases. Oh, what happened? 1, 2, 3. I returned 666. 66 output. Okay, let's resolve this. So we're given candidate index minus equals 1 if the nums 1 top is greater. Oh, sorry. I need to, if the nums, I have to minus 1 here. Then I have to take the bottom. I hope I get asked this in the interview. Oh,
no.
0 and 0, nums 1. What's happening here?
Soon. Holy.
Expected 0 and 1. Oh, there's edge cases. What are the edge cases here? 0, 1.
This is like that one thing that you were
What is this?
showing me earlier.
If I'm just gonna capture this edge case.
Yo, awesome guy.
If
give me a question
m
that
equals
you
0,
give a question that you think
then
I can do based off what you saw earlier.
Nums 1 equals. Then we'll say for I in range nums 2. What we're gonna do is we're gonna say nums 1. Nums 1 at I is equal to nums 2. Nums 2 at I. Oh, we'll probably want to return here. For I in range nums 2, nums I, list cannot be interpreted as an integer. What is it talking about? For oh, or let's just do for I in range n. Copy it over. That's kind of my solution. Let's see if it works. There might be edge case. Oh, let's see. Okay, I need to fix this case. While top and oh shoot, I'll just do while top is greater than equal to 0. If top is greater, otherwise we'll do that. Oh, there's so much edge cases in here. Out of range. Okay, wait. Let me think about this case. Let me solve this question. What's the difficulty of this question? 51% is way too much edge case. Can you follow with an O of m plus n time? Okay, what's this case? We have a 1, 0 here, and then we given a 1 with a 2, 0. Oh, okay. If the nums 1, if the top is greater than equal to 0, or no, this is what we're gonna do. This is what we're gonna do.
Yo, is that awesome guy?
When we break off,
Where that's Liam.
there's gonna be a case at the end. One of them might still have values. There might, and then we just need to copy the rest of them into the back half of that array. So we'll just say, let's print like the top and bottom here. Because one of them will still have values. So for example, you'll see here, one will still have one index. So we'll pretty much say, while the top is greater than or equal to 0, we'll just pretty much add the rest. While the top is greater than or equal to 0, we'll do top minus equal to 1. And we'll do the same thing with the bottom, but honestly, only one of them. Yeah. Only one of them. Bottom. And then we'll do nums1 at the top. Or nums1 at the candidate index. Yo, what's up? Nums1 equals top. And then we do candidate equals minus equals 1. So we pretty much just want to copy like the last little bit. We want to capture that edge case. What happened now? Wow, bottoms. Dude, this one has a lot of edge cases. While top is greater than or equal to 1. What happened here? 0. Let me think about this. So 1 is going to be... Let's just like write out a case quickly, just so I can wrap my head around that. Pretend all of these ones here are bigger than... We just have like... 6, 6, 6, 6, right? So if we start at the 2 indexes here, we put 6 here, we bring this down. We put 6 here, we bring this down, right? We put 6 here, bring this down. Now, where's our candidate? Our candidate is here. Let's try that case. Or this is the case that is breaking on 1, 2, 3, 0, 2, 5, 6. How is it? The output is that? How's that working? While the top is greater than or equals 0, top minus equals 1. Oh, sorry. There's just one little bug there. There's a little bugs that are gonna get you. Capture that. Still 2, 0. What's happening here? Expected output 2 and 2. While the top is greater than... We finished with top. Let's do this case real quick.
How does it feel to solve this?
This is hard one. This is a hard one. Especially you're asking me to do it with like 3 pointers. I need to improve on my pointers. So give me better, like keep going on these questions. Any advice on how to get better at these ones? Are you good at these ones already? So we have this, we have this, we have here. We take the larger one and then we put it here, right? And then this one goes out. So pretty much top is at -1. So top is at -1, so we don't even have to care about that. But bottom is equal to 0. So, oh shoot, I have to do top. Sorry, I have to do this. Okay, there you go. Just little bugs in my code. Little bugs in my code. 100%. Let's go. Give me the next one. Give me the next one. Give me the. I just need the next question.
Yo, let's see you write some code.
Me?
Yeah, you.
I can't write some code right now, but I just want to give a shout out. Nat2G.
Nat2G's in here?
Yeah, Nat2G's in the. Just watch out. I don't want the mod to kick you out, Nat. So just keep it civil in there.
Yo, I need another leak code question. Otherwise,
Two some.
I'll do container with most water. So you're given an integer array height of length n. There are n verticals drawn such two endpoints are I0 and I1. Find two lines that together with the axis form a container such that containers contain the most water. Yeah, I kind of already know how to solve this, honestly. But I'll mention how to do it, like why it makes sense. So pretend, let's just grab this right here. Grab my little snipping tool. Awesome guy, you actually want me to solve this? Okay, sure. Just for you, we're gonna solve this question. And get the next one ready too. Yeah, I'll tell you the whole approach. So pretty much the approach is this.
Dang.
Oh, what's going
A
on?
lot of different questions, man.
Yeah, I like it. Keep asking me questions.
Here, click that yellow thing and then it'll.
Okay.
Click this thing because it's like showing up in the chat.
Awesome guy. This is what I'm thinking. So theoretically, the largest container that you could possibly make is by using two like ones that are on different ends, right? If these ones were both tall, they would make the biggest container. Because they would make the biggest container because the area between them would be the longest, right?
What? Say that again.
Like if these were the same height, this would always be longer than if this one than like the one before it, or the one after it, because the container is wider, so it has more chance to like. So like the higher it is and the wider it is, the more optimal, like the more space, like the more water it can capture. Because essentially what it's doing
Yeah.
is it's trying
'Cause
to.
it's like bigger.
Yeah.
It's more
Oh,
space.
let me explain the question quick. So you're given an array of heights where you're given a bunch of different vertical lines, and essentially what you need to do is you need to figure out what are the two best vertical lines to pick, so that it uses up the most amount of water.
Yeah.
So for example, this one is 7 tall,
Basically
and this one's 7 tall, but they're 7 apart as well. 1, 2, 3, 4, 5, 6, 7.
Yeah.
So that creates an area of 49 in general, right? That's why it also matters how wide you are. So the brute force solution is you literally take into account every single possible vertical line and compare them, and then you calculate the amount of water that those two vertical lines can contain. Right? That's the most brute force way, but you can do this in O of n time, because that'd be an O of n squared algorithm. You could do it in O of n time. And the way you do it is kind of is like using a greedy approach where you start 2 pointers, one at the very left side and one at the very right side. And then you move in the index that is smaller than the other one. Because the one that's smaller than the other one, because you want to just try to keep the tallest one as possible. Because if you think about it, if we have 2 vertical lines, right?
Yeah.
If
like
I
you're
keep-
always limited by the small.
Yeah, you're limited by the smallest one. So to optimize, like if to see what's going to be more optimal, if I move the pointer in, I'm going to try to get rid of the smaller one. So I'll move the smaller one in, and hopefully that connects with a bigger one.
Yeah.
So you basically at every single point, you start 1 pointer on one left side and 1 pointer on the right side. And then you just move 1 pointer in at a time, calculating the maximum area that you could find by two vertical lines. And then from there, at each time you're calculating the area. How does that solution sound to you, awesome guy? Can I start coding it? And give me another question too. I like your questions. Okay.
Why is this chat not showing up?
So we'll start at the left and the right.
Man, these questions are actually kind
Are
of
these
hard.
cooking you?
Yeah, dude.
Height -1. Wow, the left. left and right, pass. We're gonna maximize, so we'll start with a float. Yep. Awesome guy, give me a good graph question or tree question. I like
No,
those
give
ones
an
too.
easy question that like a noob can learn from.
Max
or
result.
something. These are hard.
Are we always gonna be given? So we're always be given at least 2, so we're good. So what we're gonna do is today's array day. Give me the next array question then. You're literally putting me through an array boot camp. Somebody's laughing so funny over there. But don't worry. It's all good. It's all good. So what we're gonna do is 2161. Oh. You are really pushing my limits today. Let me finish implementing this one as well. Give me a good graph question. I need to have some fun with it too. My favorite ones are the graph questions. 2161, not 2162. Broski, that's crazy. Okay, let me look at this other one quick. Yo, for anyone joining in, just right now, we already finished day 7. It was a pretty easy day. I'm gonna drop the solutions soon. But pretty much, we solved the first one in about 20 minutes, and it took us only 4 minutes to solve part 2. So not the worst day. Pretty easy day so far. Now we're just literally spamming LeetCode questions for probably the next 30 minutes. Then, yeah, we could call it a day from that, and I'll see you again tomorrow. So we're gonna start with the left and right pointer. What we're going to do is we're gonna calculate the area between the left and right pointers. So to calculate the area between the left and right pointers, you get like the minimum height, the minimum height of heights of left, the heights of right, because that's what's limiting here. And then you just like to get the area, you take the minimum height multiplied by like the distance between the two ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 8. We're gonna do the minimum height is equal. Who's laughing like that? I might have to turn down the gain, guys. I might have to turn down the gain. Tell them to move over to the kitchen.
Yo, shut up. Holy. This guy is 18, took his first shot, now he's acting crazy. That's all I'm saying.
Okay. Minimum height is gonna be the area and then right minus left. And then we're gonna, if the height's left is less than the height's right, is it loading?
No.
Why is this guy laughing like that? Min height.
Oh, it's working.
We're back. We're back. Everyone's back.
Yeah.
You're back on? Oh, perfect. Sorry for the lag.
Man. Holy, weird.
Okay, let's talk about streaming schedule. So when they're gonna drop day 8. I can't do it because one of my friends' birthday tomorrow. So I'm gonna have to do it the next morning. So the one that's gonna drop Saturday at 9 p.m. PST, I'm gonna do that stream at 8 a.m.
When are we
PST or something like that.
When are we going to the club though? 11?
Yeah.
Okay, can't you?
I
do it
won't.
real
I don't
quick?
know. Maybe. Min height.
We could pregame too.
What is this? What's complaining about? Height is not defined.
Wait, what? Go to stream settings. Let me see this quick. Let's fix this. Stream settings.
Where? Oh no, it's good. You're good.
Yeah, it seems right. Why is the quality so low?
Nice. Okay. I just need to adjust this. And we'll be getting off stream in about 15 minutes after we
15?
solve all these questions. No, it's heights. Or sorry. Max result equals max of max result and what? Oh wait, max. Oh, sorry. We have to grab the area here. Cool. It's heights, not height. Post. Boom. That's a 2-pointer solution. What's the next question? Piyush, do you have any ones that you wanted to see how to do? I got like a few more leak code questions than me. I need some good ones. Maybe let me look at the list here.
Do an easy one.
Like what?
Just go in the problem list and then do the one that I'm doing. I want to.
Which one are you doing? Which one are you doing?
Go with problem list. Oh, did you already finish it already?
Where?
The initial one. Maybe go hit like plus hit plus, then go elite draw, or go down.
No more today? You ran out? You're done? 2161? Oh, okay. Wait, let me look at this. You're given a 0 and an integer pivot. Rearrange num such that the following conditions. Every element less than the pivot appears before. Every element equal to pivot appears in between the elements less than or greater than the pivot. What the heck does that even mean? What's the acceptance rate? Okay. So
When you're doing this in an interview, how does it work? You literally open up leadcode.com.
no, they just they ask it to you in a text editor. They copy and paste the prompt. They copy and paste this into a text editor. This is what an interview literally looks like.
Yeah, I want to know what that looks like.
I'll show. We'll. Awesome guy. I did a couple of your ways. Okay, I'll do this graph one quick because I like graphs. Whoa. 27%? Oh my. 27% submission rate? So you're in a city that consists of n intersections numbered from 0 to n minus 1 with bidirectional roads between some intersection. The inputs are generated such that you can reach any intersection from any other intersection and that there is at most one road between any two intersections. You're given an integer n and a 2D array of roads. This means that there is a road between intersection ui and vi, and it takes ti time. You want to know in how many ways you can travel from intersection 0 to intersection n minus 1 in the shortest amount of time. Return the number of ways you can arrive at your destination in the shortest amount of time. Since the answer may be large, return it by modulo 7. Let me see. So the shortest amount of time it takes to go from 0 to 1 to intersection 6 is 7 minutes. So you can go from like 0 to 6. Wait. Takes to go from intersection. Nice. This is a good question. The shortest amount of time it takes to go from intersection 0 to intersection 6. Intersection 0 to intersection 6 is 7 minutes. Okay, because these are the times. There are 4 ways to get there in 7 minutes. You can go like this way in 7 minutes.
0,
Okay.
4, then 6 on the very left.
So Piyush, I'm thinking like this is a bit more complicated, but when I see shortest path algorithms, especially on a graph question, I automatically start thinking Dijkstra's algorithm, which is a way that we can find the shortest path between two nodes in a graph. specifically not if there's not no negative cycles in the graph, and there's no negative cycles here. There is at most one road connecting any two intersections. You can reach any intersection from any other intersection. Interesting. So there's two ways I'm thinking of doing this question. Is using a Dijkstra's algorithm. So if we use a Dijkstra's algorithm, we can find the fastest way to get to 6. Yeah. That will only give us one of the shortest paths, but the question's a bit tricky because we want to get all of the shortest paths. Let's see, shortest paths. So how would we do this? So we know, like, in my head, I'm thinking we either use like a Bellman-Ford algorithm or a Dijkstra's algorithm. So these are the two operations that I'm thinking. Or we literally just like brute force looking all the possible operations,
Learned about that.
like a backtracking algorithm. What's the constraints? You learned Dijkstra's?
Yeah, I
Nice.
just learned about that. That one's like that's like a greedy algorithm, right?
Yeah.
Yeah.
Greedy algorithm to get to like your best.
Sort the weights of the distances or whatever, and then you're gonna start picking the smallest weights.
Yeah, exactly. So that helps us find the shortest path. But this question is a bit tricky because it's saying how many, like find the shortest path, then find all of the shortest paths there. Because there could be multiple shortest paths there.
Multiple shortest paths.
Yeah. Like you can get here from 7, or you can get here from here, or you
Yeah,
can
7.
get, so it's a bit trippy. You can go
Hey,
there's multiple shortest paths algorithm. So I'm thinking we do a Dijkstra's shortest path algorithm, but we just keep it running until it kind of finishes.
Okay, you're trying to find the short. There's multiple shortest paths. So do all the 2, 3, 5, 8. Okay, so that one's not the 2, 5, 6. But 7's not the shortest path, right? From 0 to.
It is.
Are you trying to like go through all the points?
We want to return all of the shortest paths. So
Oh, dude, there's a different algorithm for this. I just
Bellman-Ford, is it?
Not Bellman-Ford. Oh man, dude, let me look it up. I know the exact we just did this algorithm. What is it called? It's in my assignment. Let me double check it. Oh fuck yeah!
Yo.
Come on.
Chill.
University.
Don't swear. Oh
Sorry, my bad.
God.
Oh,
You're fine, you're
hecky
fine.
doodle, yeah.
Yo, see,
So he's gonna
that
tell me-
guy from the chat.
Mark Paul must be Cedric on a burner.
Yo,
There's a guy with the blue sweater.
okay, one second. I got it.
You're funny.
Funny guy. Don't click on-
Dude, you know what would be a sick app, James? So you know what would be a sick app? On one side, you could see your code. On the other side, you could see your
Oh,
opponent's
okay,
code.
never mind. Okay, so there is a Dijkstra. Yeah, that's the algorithm. That makes sense. Yeah, that's the one that.
But does it
calculates
find all shortest paths?
Yeah, from the 0 node, the first node.
Find all shortest paths?
Man, you're using Google still? Use ChatGPT.
Oh, I think it's from one vertex to all the vertexes.
Dang, a couple of goofs in this house know how to code, eh? So jokes.
Implementing this is gonna be hard, man. Honestly, I need to brush up on my Dijkstra's algorithm. I can show you how to get one shortest path. I guess let me just implement that quick. How do we get from one shortest path, and then we'll extend it to get like the next shortest paths after that. So usually with Dijkstra's, you want to use a heap,
Nice.
like a heap queue, like a priority queue.
Nice.
And what you're gonna do is you're going to
import a library like that?
Yeah, they have a heap. They have a heap data structure. So what you're going to do is Caesar is the best moderator ever. that guy deserves like half my live streaming salary. This guy.
Exactly $3.99.
So we're gonna use
Dang,
a.
man.
Let's
What
do
is
this.
going on in this?
One, I want to get the.
Holy, the munchie's hitting you, eh?
Fresh.
This guy just walked in and took a huge bite.
So for Dijkstra's, what we're gonna do is we're gonna pass in. This is gonna be a bit complicated, but I can explain everyone how Dijkstra's algorithm works. Because this is useful for like even like Google Maps. Google Maps uses this.
Let me go grab my textbook.
Grab your textbook. So we start with a priority queue. We have a priority queue like this. And we start with a node of 0. And it takes 0 to get there. So that's the first node that we're going to traverse from, right? This node 0. And then we're going to pop all its neighbors into the queue, into the priority queue. So we're going to pop like the distance it will take to get to that element. So from here, we have 4 there. And only when we pop out of the queue. Yeah, pop out of the queue. QUE is when we add to scene. Right? So we start off with 0, 0. It's the only element out of the queue. So we pop it. We'll have a scene array. We'll have a scene set. We're going to store our scene set.
I got a textbook.
Nice. This guy has his textbook out. We're going to be doing algos.
Oh, spilling nothing.
So we're going to say we've seen 0 and 0 because we popped that out. And then we look at its neighbors. Its neighbors is 1, 4, and 6.
Yo, we should talk about K-Near's neighbors.
K-Near's neighbors.
Okay.
So the neighbors are 1, 4, and 6. So to get to 4, that's going to take us 5.
Oh shit! Close that door.
To get to 6, it's going to take us 7. And to get to 1,
Dude.
it's going to get us 2, right? And since our priority queue, the 2 elements is pretty much going to be node with cost. These are the 2 elements. So since it's a priority queue, it's gonna rearrange it and it's gonna throw this like probably this 1 and 2 right here to the top. It's pretty much gonna order it.
Yeah, is this called Dijkstra's
Yeah,
algorithm?
this is Dijkstra's, but I'm gonna actually implement it.
Dijkstra's algorithm for single source shortest paths.
Earlier we
Input.
were talking about how to code, like how to get good at lead code. Give me a roadmap in the next month.
Input, a weighted connected graph. Vertices and edges with non-negative weights.
Yep,
and its
non-negative
vertex-
weights.
Vertex S. Output, the length dv of a shortest path from S to V and its penultimate vertex PV for every vertex V in V,
Yep.
which is vertexes. So we
Yep.
initialize a queue, initialize a priority queue to empty for every vertex V in the vertexes. dv is infinity,
Yeah.
and then PV is null.
Dude, that looks way more complicated than it's supposed to be.
Okay, wow. Man. Well, this
Like,
is
that's
all
some
theory.
crazy-
This is a textbook. This is all theory.
So we're gonna pop out 1 and 2 because that's the smallest. So let me just implement this.
This is how you implement this.
Let me quickly implement this Dijkstra's algorithm.
This is the
If
pseudocode.
no one has ever done Dijkstra's before, you're gonna see how to do it right now, real quick.
This is gonna be crazy.
So we start with a heap, and we need to parse the roads. What do the roads look like? The roads come with the road. You can reach any. There are bidirectional roads. The inputs are generated such that you can reach any intersection from any. So we just need to quickly parse the inputs into some sort of graph. So we're given a bunch of roads and these are the edges. We need to parse them into a graph. So we need to know like what nodes connect to other ones. So how I'm gonna do that is I'm gonna be given I'm gonna build an adjacency matrix.
Nice. Adjacency matrix. I learned about those recently.
Nice. Damn, they're teaching you a lot over there. So I'm gonna import default dict.
The short. What does it say here? The time efficiency of the algorithm depends on the data structure used for implementing the priority queue and for representing an input graph itself.
So I'm gonna use a adjacency list to represent the graph, and I'm gonna use a heap to the data structure for the priority queue.
Nice.
Is that what it says to do? You did this question in C? You're good, man. You're good. Like, can I just use Dijkstra's to solve this, Piyush? What do you think? So adjacency list equals, we start with the default dict.
For graphs represented by their adjacency list and the priority queue implemented as a min heap, it is an O absolute value of edges log.
Okay,
absolute
Piyush,
value.
this is what I'm thinking. Let me know if this is right. I'm gonna do a Dijkstra's and I'm gonna let the Dijkstra's run, but I won't return on the first time that we reach the 6. But I'm gonna instead keep it running until like we see like as many times as it could hit the 6 as possible, instead of just returning on the first shortest path. Does that work? So pretend if we land on 6 and we know that's the shortest, we don't just early exit. We let the iteration run again because maybe we might get something with that same result. If it's not that same result, we just exit.
Can you use a hash map for this?
Have you ever heard of a Fibonacci heap?
That sounds next level.
Oh yeah, it says here. It says you can optimize it by implementing a sophisticated data structure called a Fibonacci heap.
Or I think that's just a heap using an array, right?
Still, better bound can be achieved for both in
Can you
priority
use a
queues.
hash map?
What is this? Oh wow, that sounds crazy. Dude, that's the first time I've ever heard of that.
Should I buy that laptop?
Anyone in the chat know what a Fibonacci heap is? Like, that's crazy.
Fibonacci heap. Okay, I will consider this now.
Why aren't you running stuff in ChatGPT, man?
Okay, let's get.
Release my email to the public.
Oh shoot. Okay, once I implement this, me and my friends are going out to the club. So
What?
let's see. So we have our adjacency list, and the adjacency list is gonna be like a set. So this is gonna tell you who your neighbors are. I make a vector of pair, and it stores all the path. I see. Yeah, because you need to return. So I make a vector with a pair and I return, and it stores all the path. And then, what do you do there? How do you do that? I think I have a solution.
Center.
So we have a default dict from a set. So it's gonna map in the set. We're gonna map like nodes to their neighbors. And what we're gonna do is we're gonna loop do for node A, node B, time in roads. What we're gonna do is we're gonna add to the adjacency list. We're gonna add for node A. We're gonna add or default dict. We're gonna probably like a tuple here. No. We're gonna do a default dict where each element maps to a. We're gonna have a node, which is gonna be like.
Why can't you use a hash map with the set for this?
What do you mean?
Like, never mind, yeah.
dot, or let's see, no. Okay, what we're going to do is like, okay, if node A is not in adjacency list, we're gonna create a value there, node A, or adjacency list of node A equals, we're gonna have a set like this, and we're gonna have value equals, so node A, the value is gonna be node A, and then we're gonna have a children or neighbors. The neighbors are it's just gonna be a set, and for node A and node B, if none of them are in there, we just like pre-create it. Just node B value, node B set, and then what we're gonna do is we're just gonna add each other. Add to node adjacency node A dot neighbors dot add node B. And I'll do the reverse for node A. And then from there, now I have the neighbors. Now I have the adjacency list. Let's just print that out. T. We don't even need a default dictionary anymore. Neighbors. Node A. Do this. So now we have the neighbors there. So here's the neighbors. 0 has a value of 0, and the neighbors are 1, 4, and 6. 1, 4, and 6. 6 has a value of 6, and its neighbors are 0, 4, and 5. We're 6. 0, 4, and 5. 1 has neighbors 0, 2, and 3. 0, 2, and 3. That all makes sense. Oh, we need to store the distances between. So we need to not only store their neighbors, but we need to store a tuple of the neighbor plus the time it takes to get to that neighbor.
Why a tuple over anything else?
Just, I don't know. Like you can store it in an array too. But this is, so now we have the neighbors here. We have neighbors. The neighbors of 0 is node 6, that's 7 away. 4, that's 5 away. 1, that's 2 away. Let's look at like 4. Who's the neighbors of 4? No neighbors for the you can get 6 in time 2 and 0 in time 5. So now we actually parsed out the specific thing, like the adjacency list. Now what are you're given city that consists of n intersections numbered 0 to n. So you're given how many ways can you travel from intersection 0 to intersection n-1? So kind of like our start. So we're gonna start a priority queue, and the priority queue is gonna have one element, and that element is gonna be 0th element for the 0th time. We'll say while the length of priority queue exists. We're gonna be incrementing, and then I'm gonna keep a scene array of all the different nodes that I've seen. So let's just say we just keep it as that, and then we say candidate equals heap queue dot heap pop the priority queue, and that'll give us the candidate and the specific time. Now what we're gonna do, we're gonna say scene dot add. Now we're gonna see that add that candidate, and what we're going to do is we're gonna loop through all the neighbors of this candidate and then pop them into the priority queue. So we're gonna say for neighbor in where are we? In the adjacency list of that specific candidate, if the neighbor isn't seen, we continue. Otherwise, what are we gonna do? Otherwise, we're gonna add them to the priority queue. So we're gonna say heap queue dot heap push. We're gonna push onto the heap. Where's heap? We're gonna say PQ. We're gonna heap push. We're gonna pass in the specific candidate. What's the specific candidate? Or we're gonna pass in the neighbor. Or no. This is we put time in first. It goes time then candidate. So we have time and candidate. We're gonna pass in the time for neighbor. For neighbor time.
Did you implement the Fibonacci heap?
It's almost there, man. It's almost there.
Yeah.
So we have for neighbor time. We'll push into the heap. We'll push into the heap the neighbor time. The time it gets to the neighbor plus like the time we already spent getting to that specific node. And then we're gonna pass in the neighbor. And then from there, yeah, we just push all the neighbors into the priority queue. And then eventually we'll push the lowest one. And then from there, what we're gonna say? At some point, we're gonna do if the candidate is equal to 0 n minus 1, we're gonna have a result here. We're gonna increment this result. If the candidate is result, then we're continue candidate. What we're gonna do is if it's result plus equals 1. Wait. So if we got there, that means it's the minimum. Let's just break out and print this. But we need to store the path. Shoot. Oh no. Wait. That must be Cedric.
So funny.
So we push into the heap queue. Let me just look at the heap operations.
This guy's killing me, bro. Are you code? Are you all coders?
So we're getting heap queue. Heap push. Heap pop.
Okay, should I take this shot with you guys right now, or
Yeah,
should we take
so-
it? Okay,
Are we actually hitting the club or what?
This is just water.
We're getting Pizza Hut.
Go first.
We're getting Pizza Hut?
Yeah,
Where?
it's 9 minutes. It's like 3 minutes away. Liverpool's gonna drive us. Can you pass me that?
That's a strong water.
Yeah. I need to stay hydrated.
That's crazy.
Nice. Okay, the textbook's right here if you need it.
Let me see.
You want
If the candidate, yeah, I'm gonna have some.
You want anything in particular?
If the candidate,
Yeah, get me a veggie pizza.
Really?
min result equals none.
Man,
Right.
I feel like I did not learn much. These
From
were all
watching?
very hard questions.
Let-
I kind of am starting to learn like.
Dude, this is a graph question. Dude, I can explain you trees like very quick. But maybe we should start with arrays.
Yeah.
So let's do candidate. So if we get candidate n minus 1, if the min result is equal to none. Getting sleepy? You might have to. Don't worry, man. Sign out whenever you want.
Who's getting sleepy? Caesar?
Caesar. Min result. He's on his last leg. Appreciate you for joining the stream, man. Min result equals. You're actually a real one for staying the whole time. 2 hours. I know he got it on his TV or something. He got a nice TV in his house. The min result, if it equals none, the min result equals that time. And result. Otherwise, we'll see you. Thanks, Caesar. Thanks for joining in.
Peace.
Thanks for joining in. Appreciate you, man. I hope you learned something today too from that thing. I know you're already good at LeetCode, but sometimes it's nice to see it.
Word. I'll ask you for advice tomorrow,
LF
man.
if min if the time too many values to unpack. Adjacency list. Candidate. Oh, shoot. Please work, please work. Oh, we need to do 10 modulo.
What does that even mean?
What? So result modulo 10 to the power 9 plus 7. So we're solving this question. Never closed. What is this? Oh. Result mod 10 to power 9. Dude, my algorithm is way too slow. How is it slow though? Okay, if LF time is if the min result is not none and the min result is not none and the time is already greater than the min result, then we'll just return this. We don't even need to keep that algorithm going. I love streaming, man. This is fun. But my algorithm is just slow. Why is it so slow? Okay, we're going to look at solution. Dijkstra's. I'm doing Dijkstra's. I'm doing Dijkstra's, bro. Should I remove this line? How does that not work? I did the Dijkstra's algorithm. Let me look at it a bit. Now that I know the answer is Dijkstra's, that gives me a bit of help. If the min result is not none and shoot, I don't even want to get that in my queue. Ah, that was another challenge. Memory exceeded. Oh, I was doing memory exceeded. Continue. Let me ask. Now I'm gonna ask GPT how I can optimize this. Wait, let's see what people are saying online. Time limit exceeded? What? Okay, wait. What are people saying online? I'm doing Dijkstra's. So we'll go Python. Building the adjacency list, same way I'm doing. Using a min heap, yeah. Dude, my algorithm is basically the same as this guy's. Min heap result. While heap. What? What is this saying? Okay, let's feed this thing into GPT and get some help.
Feed your code into GPT and see what's wrong with it.
Yeah, I just need to know what's wrong with it. What do we have? ChatGPT. I'm gonna have to drop a solutions video right after this, real quick. Those ones slap. So, okay, that's what I'm doing. Let's see.
Wait, why did it get accepted? Oh, that's a different one.
What's wrong with my code here? You should be able to do this quick. That's not real. What? Dude, we might have to ask O1. See if that actually works.
This guy cooked you with 2161, eh?
Dude, those are
1976.
what?
Did you paste it?
Ah, they optimized the crap out of it. If this is my algorithm that doesn't work. It's too slow. Is it trippy watching this? Does it make sense? It's just-
No, it does not make sense. At least I'm getting used to reading else, and elifs.
So if time.
Yeah.
If the min result is not none and the time is greater than min result, we'll continue. Okay, what is it saying I'm doing wrong? Memory exceeded? Memory exceeded? Nah, like I can't even optimize this right now, Piyush. I'm struggling. I feel like I'm getting close, but I can do like my algorithm right now is solving it on Probably like I'm probably gonna stop streaming soon after I solve this question, but I'm not stopping till I solve this question. So my submission, I was able to pass only 20 test cases, but why is it not optimized? Piyush, do you know? For nodes. Let me study ChatGPT's output. I need to learn too. You're using set to store neighbors. This because set does not guarantee order. While the graph doesn't allow edges. Okay, sure. I'll do that. What else? Unnecessary. Okay, sure. Sure. For the condition and if min result is not none, you're marking node immediately. Okay, let's just look at their revised code. So they're building the adjacency list. Yeah, they're building that. Then they're setting up a priority queue. They have ways and distances and the ways to 0 and distances and another ways. Oh, 0 equals 1. While there's a priority queue, they pop out the current time in node. If the current time is outdated, they're seeing a distance. Okay. For neighbor time travel in new time equals that. If it's less than the distance to get to that neighbor, then we just pretty much add that. So we're storing like how short it takes to a specific neighbor. Oh, I see. Yeah. So we only want to like navigate to a neighbor using the shortest path possible to that neighbor or equal to, but okay, I see it now. Wow, that's a good question. Let me implement that quickly. Where are we? Merge sort raise. So what we're gonna do is we're gonna maintain all we're gonna maintain smallest or like best for node, and then the best to get to yeah, we're gonna say best for node. At the end, we're gonna return best for node n minus 1. That's the result. So best for node result. I don't even care about a result here. I don't even care about this. So if the time to get to the candidate is already greater than, then we'll say for I in range n, we're gonna do best for node I is equal to float infinity So let me think. I'm gonna ask GPT to help me here. If the current time is greater than the distance, what's distance here? So distance. Oh, okay. So they're kind of doing the same thing where we do float infinity. I do the same thing, but what are ways? So the distance to get to is 0 and the ways to get there. Oh, we have to track the distance and the ways to get to specific element. Then if we say like, if we have a specific node and we're already like the shortest, like we already took the longest way to get there, we just continue. Otherwise, we'll track like the number of ways to get to a specific node that's less than. If the new time is less than the neighbor, then we'll say neighbor equals the distance to get to neighbor is this new time, and the number of ways equals the ways of the node. How does that make sense? The way that we get to that specific, the ways of the neighbor is also the ways we got to that node. What's node here? EPU dot push new time. Neighbor. Ah, this is a tough one. This is a tough one. This is a tough one. Yeah. Honestly, I couldn't really get it. I'm gonna have to stop the stream here to go do some other stuff, but I tried using Dijkstra's. I'm just gonna need to play around with it a bit and understand really how it works. But yeah, this question is really tough. It has about 27% acceptance rate, so Piyush, like, good job for like solving that. I'm gonna need more time to think about it, but I think I went the generally went the good direction with using Dijkstra's algo. But I'm more used to finding the shortest path in Dijkstra's algo, not really like the number of shortest paths. So this is a really good question. I'm gonna write this one down and I'm gonna get to this a different time. But thanks for everyone for watching my stream. That's we'll be back again for Advent of Code Day 8. Today we ranked pretty good. We solved the first one in 20 minutes and the next one in literally 4 minutes. But I'll see y'all in the next video. Thanks for tuning in.